Hey deserving students, welcome to the last video that I have for you in which we discuss how I calculate the numbers of protons, neutrons, and electrons when I'm telling you to think about ions. When I'm talking about an ion, what I mean is that I have an atom with a charge on it, and the reason it has a charge is because it either has more or less electrons than it usually has. The key phrase more or less electrons than usual is that I have a different number of electrons, and that is so easy to do. In fact, the way that electrons behave is the basis for every chemical reaction. So something important to remember is that it's really hard to add or to remove a proton, but it's super easy to add or remove electrons to specific atoms. Literally all of the atoms in the periodic table, pretty much every element can form some sort of ion. But what we're going to do is we're really going to consider the ones that form very predictable ions, and those are things that we're going to talk about later. So for the purposes of this, we're really not going to discuss anything in this area. And while it's important to know that the transition metals do form ions, it gets a little bit more complicated, and so we're not really going to talk about them right now. When I'm discussing an ion, I have a very specific way of writing it down. I'll have the abbreviation for the ion, or sometimes I'll write out the entire name, but more often than not, I'm just going to say Li1+. And what that means is that I have a +1 charge. Let's go back to the assigned charges for protons and electrons. When I'm talking about charge, neutrons don't really have any charge, and protons have charge and electrons have charge, but in opposite directions. Protons have a positive charge that we assign a value of 1. Electrons have a negative charge, same, but in the opposite direction, we assign the number -1. Let me go ahead and copy that over. So the most important thing, remember, about an ion is that the number of electrons changes. If I change the number of protons, I'm not dealing with lithium anymore. From my entry in the periodic table, I have an atomic number of 3, which tells me that I definitely have 3 protons. And from the average atomic mass, I round up because the most common isotope of lithium has a mass number of 7. I'm going to go ahead and make those entries right now. And since I have a mass number of 7, if I solve for the number of neutrons, 7 minus 3 is 4. 4 neutrons in an isotope of lithium-7, which is what we're going to use. Now what I need to figure out is the number of electrons. And remember that anytime I have this specific thing happening, I have a 1+ or a 2+, or a 1 or 2 or 3-, or even 4 or 5 sometimes happens, it means that the number of protons and the number of electrons are no longer equal. So my charge value is going to be equal to the total charges on of my protons and my total electron. I also know that my charge value for this ion of lithium is going to be +1. If you think you know where I'm heading with this, work ahead and see if you're right. Go ahead and pause the video to do that. Okay, so I know that I have 3 protons. And the protons are all going to be equal to +1 each. I get that information right here. And I don't know how many electrons I have, but I do know that they all have a value of -1 each. So +1 has to be equal to 3 plus -1e. I'm going to go ahead and solve for wherever this E is. So that means that I have 2 electrons. So let's go fill it in. Cool. So what I do want to tell you is that anytime that I have a positive value for my ion, I'm going to have fewer electrons than usual. Anytime I have a negative value, that means I have more electrons than usual, and that's because electrons have a negative charge. Let's try one more. Let's talk about the fluoride ion. It's usually abbreviated like this, but what that means is that the 1 is implied, which means that I have a negative overall charge. All right, so you see that I have all the values for fluoride ion. Notice that it's a little different than what it says fluorine. We're going to talk more about naming stuff in the weeks to come, but not right now. I have a atomic number of 9, which means that I have 9 protons. And 18.998 rounds up to 19, so I'm going to call that my mass number. See if you can figure out how many neutrons this has. Go ahead and pause it and then come back and see if you're right. The answer is 10 neutrons. 10 neutrons, and I'll show you how right now. So my mass number is 19. I have 9 protons. That's how I get there. I'm going to erase this. Then the thing that I really care about is going to be the number of electrons, because remember, if I change the number of protons, I don't have the same element anymore. If I change the number of neutrons, it's a different isotope, but if I change the number of electrons, that's how I get my charged ions. My charge value is going to be equal to the number of protons times their charge value of +1, and the number of electrons, and each of them has a value of -1. So I know that my charge value has to be -1. Remember that 1 is implied. And I have 9 protons with the value of 1 each. And I don't know how many electrons yet, with a value of -1 each. I'm going to collapse that into -1e. So I'm solving for e. All right. -1 has to be equal to 9 plus, plus -1e. And then I solve. This makes -10. Which means that E is equal to 10. Therefore, 10 electrons. So something you might have noticed at this point is that if I have a positive charge in one direction, it just means that I'm missing that many electrons. So if I have a +1 charge, then I have one fewer electron. If I have a +2, it's going to be 2 fewer. And the same thing goes in the opposite direction. If I have a -1 charge, then I'm going to have 1 extra. And a -2 charge is going to be 2 extra. We're going to talk a lot more in the coming days about how we get there. So I have a couple of practice videos for you on that, and I will see you all in the next time we meet.